Hi, my name is Yazan Ibrahim, also known as Yazan Abu Ghosh. Today we will talk about Chapter 3, Part A, Information Systems Acquisition and Development, 3.3 System Development Methodologies. Let's dive into the fascinating world of systems development methodologies. It's a field that's not just about technology, but also about solving real-world business problems, streamlining processes, and even shaping the way organizations thrive in a fast-changing world. Picture this. You're in the heart of a bustling company where every team relies on interconnected systems to keep things running smoothly. From sales data to compliance with tax regulations, every click, number, and decision depends on finely tuned software systems. But creating these systems isn't just about writing code. It's about designing a solution that works seamlessly for the business and the users. This process begins with the concept of systems development methodologies. Imagine them as the blueprints or frameworks that guide how organizations create and maintain everything from basic software applications to complex business critical systems. These methodologies provide structure, ensuring projects are efficient, collaborative, and most importantly, aligned with business goals. But building applications can be overwhelming. Systems today are more intricate than ever, and businesses need them yesterday. This urgency has led developers to adopt various approaches, each tailored to unique challenges. Business application development, the life cycle of innovation. Every business application is part of a structured journey known as the life cycle. Think of this process as a staircase, with each step building on the one before it. Each phase ensures nothing is left to chance. From planning and deployment to maintenance and eventual retirement, every aspect of application development is orchestrated to optimize control and results. Applications typically serve one of two broad purposes. The first is organization-centric applications, where the goal is to manage data for internal processes. Picture a system that collects, organizes, and shares vital information with different departments, like sales figures flowing seamlessly to accounting and compliance teams. These systems often rely on classic development techniques such as the SDLC or System Development Lifecycle, a tried and true approach that ensures rigorous attention to detail. The second category is end-user-centric applications, tailored to give users insights and tools that make their jobs easier. These include systems like Decision Support Systems, DSS, or Geographic Information Systems, GIS. These applications are more agile in their development, reflecting the dynamic needs of end users. Every application begins somewhere. Maybe it's born from a new business opportunity, like the chance to automate a process that used to take hours. Or perhaps it stems from a problem, an outdated system that's slowing everyone down. Regardless of the spark, the development process always ties back to business drivers, those critical objectives that ensure the project supports overarching organizational goals. But here's the catch. Applications aren't just about technical specs. The objectives must be smart, specific, measurable, achievable, relevant, and time-bound. Why? Because clear goals help prioritize tasks, align teams, and measure success. Think of it like building a house. Without a detailed plan, you could end up with a beautiful roof but no foundation. From blueprints to building, the System Development Lifecycle, SDLC. The System Development Lifecycle, or SDLC, is the backbone of many development projects. It's like a map for traveling through uncharted territory. It shows you where to start, which steps to follow, and how to reach your destination. There are many SDLC models to choose from, each with its own strengths, but let's zoom in on three common ones: the waterfall model, the V-shaped model, and the iterative model. The waterfall model is perhaps the most well-known. Imagine water flowing step by step down a series of rocks. Each phase, the feasibility study, requirements analysis, design, implementation, testing, and maintenance, flows into the next. It's straightforward and works best when requirements are clear and unlikely to change. But that predictability comes at a cost. It can be rigid. If something unexpected arises, backtracking can be tricky, and users must wait until late in the process to see results. Now let's picture the V-shaped model. Imagine the V as a bridge connecting development and testing. Each development step is directly linked to a testing stage, ensuring that the system's design aligns with its intended purpose. This model works wonders for projects requiring precision and thorough validation. Finally, the iterative model. Think of an artist creating a masterpiece in layers. This approach builds systems piece by piece, testing and refining as you go. For example, developers might start with a basic framework, like a bare-bones e-commerce platform, and add features with each iteration. By the time they're done, you have a fully functioning website with shopping carts, ratings, and security features, all fine-tuned for user satisfaction. Each model has its time and place, and the choice depends on the project's demands, the organization's needs, and the stakes. A closer look at SDLC phases, bringing ideas to life. Now let's walk through the SDLC phases. You might think of them as the foundation, walls, roof, and interior furnishings of a well-designed building. Feasibility study. Before lifting a single hammer or writing a single line of code, developers evaluate whether the project is worth pursuing. What benefits will it bring? How much will it cost? Imagine this phase as the blueprint stage, where every potential option is carefully weighed. Requirements definition. Here, the team collaborates with users to identify exactly what's needed. It's not just about features, it's about understanding how the system should function in the real world. Without this step, it's easy to end up with a system that checks all the wrong boxes. Design and development. Things start to take shape. Developers sketch out how the system will work, creating flowcharts, crafting algorithms, and selecting the right tools and languages. Whether it's choosing Python for analytics or JavaScript for interactivity, every choice lays the foundation for coding, testing. Now, picture inspectors coming in to examine every aspect of your newly constructed building. Testing ensures the system is secure, efficient, and ready to handle real-world challenges. From unit testing to full-scale integration, nothing should be left unexamined. Implementation. This is the big moment. The system goes live. Developers work closely with users to ensure a smooth transition. It's like moving into a new house. Everything has to be functional, polished, and ready for everyday use. Post-implementation review. Even after the system is up and running, the work isn't done. Teams assess what went well and what could be improved. Did the system meet its goals? Were users satisfied? Like a checklist after a project's completion, this phase ensures lessons are learned for future development. Final thoughts: more than just code systems. Development isn't just an exercise in technical skills, it's a dance between business needs, human behavior, and cutting-edge technology. Each phase, methodology, and decision contributes to the bigger picture. A system that not only functions, but empowers users to achieve their goals. So, whether you're a developer, a project manager, or someone simply curious about how software shapes our world, remember, designing systems isn't just about technology, it's about crafting solutions for better, smarter, and more connected lives. By focusing on engaging storytelling, breaking down the technical language, and presenting relatable examples, this narrative transforms a dense topic into a captivating script suitable for an educational video. Picture this. You're about to build a magnificent skyscraper. It's going to revolutionize the city skyline, sleek, functional, and ahead of its time. But there's a catch. Every phase of construction, from the foundation to the rooftop garden, is riddled with risks. One wrong move, one overlooked corner, and the entire structure could crumble. Enter the safety inspector, the IS auditor of our metaphorical skyscraper. In the world of software development, this skyscraper is your system, your application, your innovation. And just as the safety inspector ensures every beam and concrete slab aligns with regulations, an IS auditor safeguards the system development lifecycle, SDLC, by overseeing risks, standards, and controls. Without their watchful eye, what looks like a flawless design on paper can often turn into a house of cards. The silent partner in SDLC is auditor. Let's paint a picture of what the IS auditor does as a project manager darts from phase to phase of the SDLC. You might imagine the IS auditor as quiet but calculating, a shadow you barely notice until they step in at critical moments. And when they do, their role is crystal clear. Identify risks, minimize exposure, and ensure the system isn't just functional, but robust. Whether the project is in its earliest brainstorming phase or approaching its final implementation, the IS auditor ensures two questions are never forgotten. 1. What could go wrong? 2. Do the benefits outweigh the risks required to prevent that? For example, imagine you're in the middle of designing a futuristic banking app meant to process thousands of transactions per second. The IS auditor keeps an eye on the development team's progress by attending meetings, asking tough questions, and collecting key documentation from every step of the process. If, say, the project team plans to launch the app without adequate backup and recovery protocols, the IS auditor flags it, explains the risk of potential data loss, and recommends cost-efficient solutions. But wait, there's nuance here. A good IS auditor also knows that not all controls are worth their cost. Implementing a multi-million-dollar solution to guard a relatively low-risk system could be akin to installing a vault door on a garden shed. Behind the scenes, the checks and balances of project oversight. Now let's zoom in. An IS auditor reviews not only the risk landscape, but also whether the project management team is running the show efficiently. They're checking if leadership is pulling the right strings, threading stakeholder involvement, reporting progress effectively to senior management, and managing costs like a maestro orchestrating a symphony. Picture a conductor who misses the crescendos or loses track of the flutist. It throws everything out of sync. For a software project, the IS auditor makes sure no department is out of tune, from stakeholder sign-offs to structured levels of oversight. Every key deliverable, every budget forecast, every risk management document must align harmoniously. Adequate documentation isn't just paperwork, it's the GPS that leads the project to its destination without major detours. And when it's time for approvals, the IS auditor ensures someone accountable, think of the systems development team or user management, is taking ownership of both the costs and operations of the system. Software development methodologies choose your adventure. Now that the IS auditor's role is clear, let's shift gears to the exciting, almost kaleidoscopic world of software development methods. Each method is a different pathway to achieve the same goal. Building software that works. The road you take depends on the landscape of your project. 1. Prototyping, the test kitchen of software design. Let's start with prototyping. Think of it like cooking up a new dish. You don't start with the perfected recipe. You experiment first, taste testing each vital element. In prototyping, developers create a working model early on, focusing on screens, reports, and features most relevant to the end user. You can almost imagine a developer standing over their creation like a chef, asking the users, does it need more salt? The catch? Sometimes users want to start serving the dish before it's fully cooked. Prototypes can give the illusion of completion when key ingredients like scalability, security, and auditability are still missing. Yet when done right, prototyping reduces risk and fosters critical dialogue between developers and users. 2. Rapid application development, RAD. Minimal time, maximum impact. Next, there's RAD, or rapid application development, the sprinter of the development world. Small, fast-moving teams and evolutionary prototypes keep the process light on its feet. If prototyping is like creating a dish from scratch, RAD is closer to a TV cooking show, quick, purpose-driven, and relying on preset ingredients. But be warned, while RAD is excellent for building individual systems quickly, it doesn't plan for the broader menu of enterprise-wide needs. 3. Agile development, the flexible dancer. And then there's Agile, the improvisational dancer on the software stage. Agile moves in short, iterative sprints where priorities can change based on what the team learns after each leap. You can think of Agile as diving into the unknown. There's no rigid upfront plan. Instead, the team adapts, grows, and reshapes its choreography to match evolving goals. Unlike traditional SDLC, Agile doesn't obsess over perfect documentation. It places trust in people's tacit, in-the-moment knowledge, which means small teams must communicate constantly, holding daily check-ins to ensure everyone is in step. 4. Object-oriented development, building with Lego blocks. For those who love modularity, object-oriented development, OOSD, is like designing with Lego bricks. Instead of hammering each software piece in isolation, developers work with pre-built blocks called objects. These objects have predefined attributes and methods, making them reusable and infinitely customizable. Imagine building a car. The engine, the wheels, the steering wheel, these components can all be reassembled into different vehicles. That's OOSD. Its real strength lies in allowing developers to focus on the big picture rather than being bogged down by minute details. 5. Web-based development, the matrix of integration. Web-based development takes a different approach, acting as the matrix that binds systems and applications. Its central goal? Seamlessly connect platforms, crush silos, and ensure code modules speak the same language. Using tools like XML and SOAP APIs, web-based development ensures not just functionality, but the kind of integration that means you only need to update your customer's change of address in one place instead of 5. The IS auditor's wisdom, balancing innovation and control, whether it's evaluating a high-speed DevOps pipeline or ensuring that agile teams keep track of critical controls, the IS auditor's role blends vigilance and foresight. It's not just about pointing out risks, but recommending solutions that respect the unique rhythms of each development methodology. So the next time you look at that seamless banking app, that integrated enterprise system, or that snazzily designed website. Remember? Behind it lies not just innovation, but balance. And the IS auditor, they're the unsung hero walking the tightrope of success, whispering in the team's ear, risk controlled, processes optimized. By navigating this fascinating dual dynamic of oversight and creativity, IS auditors and software developers remind us of the greater truth. In the art of system development, vision and vigilance must dance hand in hand. When it comes to selecting and acquiring the right hardware and software for an organization, the process is much more than just picking out a few pieces of technology. Imagine this as designing the foundation of a smart, interconnected infrastructure, one that supports not just today's needs, but also the unknown challenges of tomorrow. At its core, this complex process is about aligning technology with the organization's goals, environment, and long-term vision. Let's begin by exploring hardware and software acquisition step by step, crafting a strong blueprint, the power of specifications. It all starts with crystal clear specifications. Think of these as the building blocks for constructing a proposal that vendors can respond to. Organizations often create a formal invitation to tender, or ITT, sometimes called a request for proposal, RFP. Here's where the details shine. Every requirement, from how the equipment will be used to the tasks it needs to perform, is laid out. The environment in which the hardware and software operate is also meticulously documented. For example, does the organization need centralized systems or decentralized setups? Will the IT infrastructure require rigorous security assurance levels, or is adaptability a key consideration? Whether it's major application systems, performance workloads, or unique processing needs like client server or real-time databases, every detail paints a clearer picture of what's required. Imagine being in charge of selecting hardware. This might mean specifying the right CPU speed, memory requirements, or networking capabilities. Will the system demand robust peripherals like magnetic disk drives, tape drives, or cutting-edge USB storage devices? Even the number of users connecting at the same time must be factored in. Each question narrows the choice and ensures every piece of hardware aligns perfectly with the organization's mission. Expanding perspectives beyond hardware. But hardware alone isn't enough. What about the software that powers it all? From operating systems, database management tools, and communication software to access control protocols and job scheduling programs, each piece of system software has its role to play. This expansion includes integrating support structures like backups or training programs for users and technical staff, so the organization continues running smoothly, even in unforeseen situations. Adaptability is a cornerstone here. A good solution isn't just a one-time fit, it needs to grow with the organization. This means planning for future upgrades, ensuring compatibility with existing systems, and even laying the groundwork for a seamless shift to newer platforms when the time comes. At the same time, constraints like budget, timelines, or existing capacity shape what's possible. The human touch, evaluating vendors. When it comes to selecting a vendor, the goal is simple. Find a partner who delivers the best combination of performance, security, and cost effectiveness. This process is as much about trust as it is technology. Testimonials, visits with other clients, and competitive bidding are essential steps. Imagine walking through a rigorous evaluation process. Vendors don't just propose solutions. Their financial stability, support capabilities, and upgrade potential all come under scrutiny. Can they deliver on time? Is their pedigree traceable with no risky grey market components? How about the security of their equipment? Can they prove it won't compromise the organization's integrity? Metrics like system response time, throughput, capacity, and compatibility become the tangible benchmarks for performance. But just as important are qualitative considerations. How easy is it to use the system? How quickly do they fix problems? And do they truly understand the organization's business goals? Each of these helps narrow the field to the vendors that best align with the organization's needs. Conclusion and the role of the IS auditor. Finally, let's not overlook the role of an IS auditor who ensures the entire process adheres to the highest standards of security and performance. Their job is to investigate, verify, and ensure that the chosen solutions are not only technically sound but also implemented in a way that minimizes risk. From reviewing RFPs to monitoring test pilots and user evaluations, an IS auditor tracks every detail and ensures nothing falls through the cracks. But here's the key takeaway. Hardware and software acquisition isn't just an IT decision, it's a strategic investment in the organization's future. By examining every possibility and prioritizing adaptability, businesses can build systems that are secure, scalable, and ready for whatever lies ahead. Thank you for watching, and as always, continue learning, stay curious, and we'll see you next video.